Okay, so today we are going to talk about circular motion, and this is lesson one. This is a topic in A-level physics. Okay, so we'll start off with something a little bit easy, and we're going to just talk about describing circular motion. Okay, so what kind of things move in a circle? All right. Okay, so it's quite easy, but it's just to give you a little bit of a feel for the topic. So obviously you've got the wheels of a car. You have the Earth's orbit. I know that's elliptical, but it can be treated as moving in a circle. You've got the hands of a clock. You've got DVDs and a laptop. Actually, I don't know if people still use DVDs, but that's okay. And yeah, you've got like the drum of a washing machine. There are plenty of other examples, but this is just a few basic things just so that we can dip our toe in the water. All right, okay, so moving on to some key points. Okay, so the first thing you need to understand is that object moving in a straight line has no angular component. Okay, so if you see an object moving in a straight line, you don't need to worry about the angles too much. The thing you need to understand is that an object moving in a circle, with a circular path, it is moving at an angle. Okay, so that's where you need to start thinking about angles, and that's where this term comes about, angular displacement. Okay, so what is angular displacement? So angular displacement is the angle through which an object has moved along the circumference of a circle. Okay, so the main thing you need to worry about there is that angular displacement is just an angle, okay, and we use theta to measure that angle, okay, uh, theta being the symbol. So if you're looking at this diagram, so you've got this little tiny blue ball on top of the circle. Now, if it moves all the way through the circumference of the circle right back to where it started, then it's moved at a 360-degree angle, right? Yeah, makes sense. And if it moves all the way to the right hand side of the circle, then it's moved at a 90-degree angle. Okay, so this is where that term angular displacement comes about. All right, so it's just the angle through which an object has moved along the circumference of a circle. All right, okay, great. Now we're going to have a look at this term arc length. Okay, so what is meant by the term arc length? Okay, arc length is just the distance along a curve. All right. So in other words, it's just a portion of a circle circumference between 2 points. Okay, so that can be a bit misleading, but all it is, the reason why it can be bit misleading is because arc length can be the full length of the circumference of a circle. It doesn't have to be the partial length of the circumference of a circle. So the best way to think about it, arc length is just length. That's it. It's just length. So if you get like a tape measure, and you make a circle using that tape measure, and then you read the length of that tape measure, that's all you do is you just call that arc length. And if you take, a bit of that tape measure, to take two random points, the length between those random points, that's going to be the arc length. Yeah, easy. All right, great. So now, moving on, now that we understand these two terms, arc, angular displacement and arc length, let's have a look at the formula used to calculate angular displacement. Okay, so the formula used to calculate angular displacement is just angle in radians equals length of the arc divided by radius. So in other words, it's just angle equals uh, arc length divided by radius. Angle being in this case angular displacement. Yeah. All right. Okay. Cool. So in terms of symbols, the way we can describe that is theta equals s over r. Theta is the angle in radians. S is the arc length in meters, and r is the radius in meters. All right. Okay. So key point you need to understand here is that angles can be measured in both degrees and radians. Yeah, so just remember that angles can be measured in both degrees and radians. So the thing that you need to be able to do for your exam is that you need to be able to convert between the two. So if you have like degrees, then you need to be able to convert that to radians, So the way in which you do that is just radians equals degrees times by pi over 180. So one more time, radians equals degrees times by pi over 180. So now if we were to flip that, let's say, for example, you have the radians, and you want to get the degrees, then all it is you just use this formula where degrees equals radians times by 180 over pi. One more time here, degrees equals radians times by 180 over pi. Yeah, quite easy, right? So just moving on. The last thing you need to remember is these are just some typical values which I think you should just memorize, honestly. It just makes life a lot more easier. So yeah, so 360 degrees equals 2 pi radians, 180 degrees equals pi radians, 90 degrees equals pi radians over 2, and 45 degrees equals pi radians over 4. Okay, great. So that's the first lesson on circular motion. If you have any feedback for me in terms of how this lesson can be improved, please leave some comments below. Thank you.